Hello again, I'm Ross Laws, and this is part 2 of the Introduction to MIB video series I'm doing. This video will cover segmentation of your data this time around, and the various operations, hotkeys, and functions and tools you can apply to your image to create a segmentation. So this is the hotkeys from the first video if you just wanted to review them again. And these are the hotkeys I'll be using in this video. There may be some others, but I'll mention them along the way. MIB's shortcuts can be changed by navigating to Menu, File, Preferences, Shortcuts. I would recommend as well taking note of the shortcuts mentioned at the start of this video for future reference in the video. So before you do anything, you need a segmentation. And the easiest way to do that is using the brush tool. Anybody who's used any segmentation packages before will be familiar with tools like this. It just allows you to manually draw around an object of interest. So if I zoom in here, I can hold Control and scroll to make the brush size bigger or smaller. There are various tools you can use once you're happy with the area you've segmented. I'm not going to be too precise in this case. So you only have to draw around the outside of the object. What you can do is then fill it in with F. Once we have that, we can now begin to add it to something else like the mask or a material in a model. If I do add on the left hand side, then it's going to ask what I want to call the new material. Let's call this blob. This list is just a list of model types you can choose from for your model. Each one of these can hold a different amount of materials, which is essentially separate objects in the image. We are going to go with 255 for now. So you can see I have a red material here now called blob. I'm going to hit A to add it to that. So that is now part of that material. If I make another material, and I do a selection and add it to that, then it's going to overwrite the original material there. Not because it was done next, but because a pixel in an image in MIB can only belong to one material at a time. However, a pixel in the image can belong to the selection, mask, and a material at the same time. If I click on the mask here, then hit A, and just hide the model for a second with this middle panel here, you'll see that the mask shows up as this purple line here, and it's occupying the same area of space as the model. So that can be useful sometimes later on if you want to add every object you segment to the mask and a different material. Your mask can include all of your objects as one material, but they can all be separate materials. Finally, I can have a selection on top of this as well. So the key takeaway is you can only have one material, one pixel in one material at a time, but have one pixel in the material, mask, and selection at the same time. So if I want to get rid of a selection, I can hit C or click the button down here. I'm just going to move to a different object now. So what I can show you now is when you want to segment an object, some of the other features that are available. So if I just select this area here and hit F again to fill it in, then I'm going to hit A and add it to blob 2. I could add it to blob as well, so you could make all of your objects as one material if you wanted to. So say with this object here, I've made a mistake, then I've added that mistake to the material. You could undo it with Control-Z. If you've already done multiple other steps and you have exceeded the undo buffer, which is potentially 8 steps beyond or something, then you can draw over the object. This is what I tend to do, is just draw a loop around it like this. Hit F to fill it. And then if you hit S, it will subtract it from that. So to give you a better idea of what I've just done, if I hit S now, it will subtract this green selection, the bright green selection, from the green blob and leave a hole in the middle. If we hide the image for a second, it'll be more clear. So that is S, or clicking the button here. There's another feature as well called replace. And what that does is replaces the current material with the new selection you've made. So rather than this one here, it's going to replace it with this one here when I hit R, or the button in the selection panel. I'm not going to go into massive detail right now about how all of these features are useful and what situations you use them in. I'm just going to teach you the basics, and hopefully you'll be able to go on and expand on that yourself with just trying out some of the tools and using the selection and segmentation tools. So far we've only worked on a 2D slice. Now I'm going to expand that to 3D. So I'm just going to clear this by subtracting it from the image and find a fairly consistent blob to segment quite quickly. So I'm just scrolling through the slices in my data in 3D. So I've scrolled through around 10 slices there and segmented this object on each one. So now I can perform the same operations I was performing before in 3D. To do any 3D operation with the selection tools here, you need to do shift click. So to fill all of these at the same time, I'm going to do shift F. Then if I want to add them all at once to the material, I would do shift A. And that's going to do the operation on every single slice. I could also do shift S. I don't really have anything to subtract it from right now, but you can do that as well if you want to subtract all of your selections on every slice from an object. Shift C to clear all of the selection at the same time. So that's gone now. I've just done Control Z there to bring it back, if you were wondering. That just about covers the selection panel here. Also, if you want to remove any selection before you add it to a material, you can do Control and click. So if you hold Control and click down, you can just erase the selection. If we move over here in the segmentation panel, we can select the mask and then click Shift A to add all of our selection to the mask. What the mask will allow you to do is mask off an area that you've already added to your materials. And what you can do with the mask, as the name implies, you can use it to mask off an area in your image. So if you check the masked area checkbox in the segmentation panel, what it will then allow you to do is paint in the area of the mask without painting outside of it. So it contains your selection to that area. So the mask can be used with any of the segmentation tools as well. So if you have say a cell membrane selected already and added to a material, you can add that to a mask as well. And what you can do then is threshold within the cell in 3D, so that you're not including everything outside of the cell. It can also help you stay within the lines of an object as well. If you're, say, segmenting the nucleus of a cell, you don't want to be segmenting outside of the cell, so it'll keep you within the cell membrane. Another thing with the segmentation panel, if I select another object, like this one here, then add it to this material, I'm just going to hide the mask as well. So I have two objects in this image, and I could have this in 3D as well. What you can do is right click and show selected material only. Then it will only show the material you have selected. However, the mask always shows up. I'll now show you the tools in more detail. So the brush tool, there's a couple of options I'm going to go over for now. I'll leave these other options for when I do a more advanced description of the tools. But you can change the radius manually here. You remember earlier I said you could do Control click. So yeah, I'm just holding Control down and scrolling, sorry, not clicking. I can also change the eraser multiplier and have it the same size if I just put 1 times. Or switch it up and have it 3 times the size. Which can make it a bit easier to delete whole areas of selection if they're wrong. The next common tool you would probably use is the black and white thresholding tool. So to use the black and white thresholding tool, it's actually a lot easier when you're looking at other data types. 3D electron microscopy data doesn't have particularly good signal to noise, so the signal to noise ratio is quite low. So in this case, I can use one of these lighter areas here. Before you use the thresholding tool, you're going to have to assess which threshold you're going to use. So to do that, what you can do is look at the rough average intensity in the region you want to threshold, So in this case, if you look at this number here, represented by R, if this was a multi-channel image, then R would be the red channel in an RGB image. But in this case, we only have one channel because it's a grayscale image. So that number, say here, is 200, 243, 193, 206, 195. So we're looking at somewhere between 190 and 240 potentially, or maybe even higher, 250. So outside of the object, our intensity could be around 117, 158, 93, 104, 130, 115. So look at about 90 to 150. So if I set the low intensity threshold to about 170, and the high intensity can stay at 255. Because we want an area that's lighter than everything surrounding it, we want all of the pixels that are above 171, so we're taking it up to the max intensity here. Now the ideal threshold for any image or any object is a threshold that gives you the optimum coherence to the border of the object with the minimal amount of erroneous selection around the outside of the object. So if I hide the image here, what you'll be able to see is the fact that we have a lot of stuff segmented that we don't want to have selected. However, a lot of these smaller particles can be removed with extra steps. For now, I'm just going to show you how to use the threshold tool, but later on I'll get into detail about how you would remove things like this as well. So the thresholding selection that we have here is just like any other selection you would have in MIB. So like the brush tool or any of the other tools I will show. If I take the brush tool, I can manually clean up areas by doing Control click. And remove the erroneous selection around the object. If we look at that without the image now, you can see that it's removed a lot of the debris around the outside. This is a slightly slower way of doing it, unless you're just doing one object. You can also fill in this object as well to make it more substantial and solid. So any operation I can perform on the selection from using the brush tool can also perform on the thresholded layer here, the thresholded selection as well. So what I can do is do A and add it to the material. Go back. I can also do R to replace my current segmentation. Say if I'd started with a manual segmentation that I was unhappy with, I could then replace it with this segmentation instead. You also have the added bonus that you can threshold in 3D. So if I select black and white thresholding again and choose this checkbox here, so this means that it's going to do every single slice. This 3D checkbox in the selection panel is slightly different. what I would recommend is you can test your threshold in 2D on a good slice. So if we go to slice deeper into the dataset and I click on the low threshold box here and hit enter. I'm going to do this in 2D first. Then we can have a look, see what the threshold looks like. This is less resource and memory intensive. If you're happy with that, what you can then do is check the 3D checkbox. Click the box for manually entering the threshold in, the white area here where you can enter the text, and hit enter. And what that'll do is apply this threshold to the entire dataset. If you zoom out now, you can see what it looks like. Hide the image as well. So a quite nice segmentation of the objects we're interested in, these lighter areas here. But we also have an erroneous selection of some of the other regions in the image that we're not interested in. What you can do to get around that problem is restrict your threshold to a specific area in the image. So if we're just going to do one area at a time, or one object at a time in this case, we can create a mask around the object, as I talked about earlier. So to do that, I'm going to select the brush tool, and I'm going to find where the object begins, and I'm just going to clear my previous selection and show my image again. So I'll start by selecting where the object is. So what I'm going to do here is I don't have to select where the object is on every single slice. I can select, say, every second or third slice. Then, when I've done that, use the interpolation tool to fill in the slices that I haven't done. So I'm going to use Shift F first, and that'll fill in all the selection I have made, and then hit I to interpolate all of this selection here. So now I have a region around my object which I can threshold in. But what I have to do first is add that to the mask with Shift A, then check masked area. If I then return to the black and white thresholding tool, the threshold I used previously for the other object should work for this one because it's the same kind of object. So if I click on the white text box and hit enter, now you can probably get away with doing 3D straight away for this. If you notice, that was quite quick because it's just this smaller area. We still have a lot of erroneous segmentation around the outside, however. So one way to clear that up is to do a 1 pixel erosion of the selection. So if I say Shift Z for erode, and that'll do every single slice. 3D in the selection panel for erosion and dilation does a different thing. It uses a 3D kernel to detect not only pixels on each slice, but the slice above and below as well. So it's actually looking at smoothing, eroding, and dilating in 3 dimensions rather than just on a slice at a time. We wanted just to do a slice at a time. Just make sure that's number 1, and then hit Shift Z. if we look at it without the image, we can see that there's a lot less of the erroneous segmentation around the outside now. If I do Shift F, fill that in, then Shift X to dilate the image again, this selection again, sorry. Just going to do another Shift F because I did it at the wrong time. What we have there now is quite a nice segmentation of the object we were looking at. We still have some erroneous selection around the outside. What we can do is do Shift R and make this into a mask. Then we can use a tool called the Object Picker. So you can use this in 2D or 3D. 2D is just going to work slice by slice, quite quick, could be even quicker than 3D sometimes, and allow you to go through and select objects from your mask or model. I'm just going to clear that with Shift C. But what I'm going to try instead is to do 3D object picker. So you have to have this selection option checked here. So what it's going to do is it's going to look at how the object is linked to this object in the slice above and below as well. If we hit recalculate, it calculates what is a connected object in the image. Then we click on it, and what we can do if we hide the mask in the image and zoom out a little bit is see how well that has performed. So we've lost almost all of the erroneous segmentation around the outside now, giving us a nicely segmented object, which we can add to a material to make it a permanent segmentation rather than the selection. I'm going to do Shift R in this case to replace anything I've already got. And there you have it, a nicely segmented object. If you wish to save your model, go to Models, Save Model As, and then you get a variety of options for what you can save the model as. I won't go into massive detail about all of the formats right now, but the default format, the .model one, which is the current default format in the newest version of MIB, is the best one for saving your segmentation as you progress. So what I tend to do is save successive versions of my model, model version 1, version 2, version 3, probably running about 5 different versions at the same time, deleting the older ones as I go. What this means is if there's any problem with the model, like the file ends up becoming corrupted somehow, or any other kind of issue you might be having, you can always go back to an earlier segmentation that you've got and an earlier model you've got saved. This means you're not going to lose all of your work in one go. Just don't keep all of your eggs in one basket, basically. So I'm not going to go into loads of detail about the other formats, as I said, but you have the Amira formats you can use. So you can save your model in any of these and then open them up in Amira as well. The one I mainly use is Amira Mesh Binary, and that is the simplest one I've found. You also have this hierarchical data format. As I mentioned, when it comes to saving the images, you can save your model in this format and then open it up in Elastic to have a pre-segmented region to use as your training labels in Elastic. This is the older MATLAB format you can use. If you have any old models from, say, other people in your department who are working on MIB, and you're carrying on their work, you can use this. Contours for iMod, I don't know much about that format. Same with the volume for iMod. You can save your model as this isosurface, STL. This is useful if you want to 3D print or open your objects in Blender, for example. TIFF format, and the TIFF format's the other really useful one. It takes up a bit more space than the MATLAB format, which is quite memory efficient. But the TIFF format can be recovered quite a bit easier than the dot model if anything goes wrong. You can load up the TIFF model as an image in MIB and resegment quite easily from that your various objects. So what I tend to do is save my model as a TIFF format every so often, just as a backup as well. And that's about all I'm going to cover for that for now. So we're going to go with the default format for now, which is the MATLAB.model file here. And just save this as labels v2. What that's going to do is it's going to save all of the materials I have. So you can't see them at the moment, but I have some other materials as well. If you want to just save one material, what you can do is select that material, right click, show selected material only, make sure that's checked. Then if you go to models again, save model as, just call this V3 for speed, and then you can use the TIFF format. Just going to go with labels V3. The TIFF format is going to ask you whether you want to set the intensity of the material you've chosen to 1 or 255. This is just coming up because we had the show selected material only option checked. So I'm going to say yes. And then it's going to ask you if you want to save as a 3D TIFF or a sequence of 2D files. So the key thing to remember is saving your model as a TIFF. It's saving it as kind of like a binary image, but not two colors. Your background will be black, so 0, and then all of your objects will be assigned a different intensity or color or gray value in the image to separate them from each other. So in this case, I'm just going to select 3D TIFF. What we can do, just to show you how that's worked, if I open the image up here, it looks black. I'm just going to shift the display values, minimum, maximum. So we do have a binary image in this case because we only had one material saved in the model. If I scroll through, you should be able to see it. There it is. So that's our binary image of the material we've just saved there. So try not to get too confused. If you have saved anything as a TIFF, it's potentially in the same format as your images, so just be aware and make sure you label things and put them in folders to keep everything organized. You may want to export the model to something like a mirror. You can do one at a time with that as well, if you just select a mirror mesh binary, and save. And it's going to ask you the same thing as with the TIFF files. So we're just going to say yes, set as 1. There you go. I will warn you, doing that for the Amira files take up the same amount of space for the model as the image. So they are quite large. So if you're trying to save every single object separately as Amira files, then it's going to take up a lot of space. What I'm going to do last is show you how to display your model or segmentation in 3D. We have the object that I've just segmented here, and what you can do is, if you want to just display one of your materials, right click on the material, then select Show Selected Material Only. After that, go to Model, Render Model, and MATLAB ISO Surface. You can use the default parameters here. Click OK. And then you can enlarge this window. Let me just get it from the other screen. And click and drag to rotate the view around. So this can be quite nice for quick renderings that you can use for presentations, for example. If you want to do more advanced 3D display and potentially analysis as well, you can use something like Amira or Amaris or some of the other paid packages if you have them. So if I just close this window, I'm going to right click on the material now and uncheck show selected material only. So if I zoom out here, you'll be able to see that I've actually already segmented some of the other objects in the image as well. I'm now going to render all of them at the same time. Do the same thing. So MATLAB ISO surface. Default settings in this case. If you do have any trouble, you can always turn smoothing off, put it on 0. Some lower end systems can't handle this very well, and so you can always just turn smoothing off if it's not working. And keep this field empty if you want to render everything. You can also just put one of the material numbers on names in here, rather than doing right click show selected material only. Now this will take longer because there's more materials. So that's finished now. I can do the same again, same as last time, and maximize this window. So we can rotate this round now and have a look at the different objects in the image. And there you go. So I hope that's given you an idea of how you can segment some features in your images and then display them in 3D. Future videos will be focused on using some of the tools I've shown in these first two introductory videos in a lot more detail. I will also post updated versions of the first videos as well, so I can fill in any gaps from feedback that I've had, etc. So see you around.